Okay, so I just invested into a new computer here. It's a Samsung Chromebook. See how it works out, see if the investment was worth it. But I wanted to start doing videos for my physics labs and my chemistry labs. I'm taking two right now at the same time. So just a disclaimer, I don't say things too well sometimes, but I'm going to try and go through this lab 4 physics lab. It's the pendulum and calculations of gravity. Um, so, starting out, you'll see when you go through, you have to set, there's a setup for this lab. We'll go through that first. One of the items I'm going to have, or I have for this lab, is a stopwatch. I've got my calculator. You're going to need a graphing calculator, something similar to this, so you can do standard deviation. It makes it easier. Um, and also, if you take a look at the wall back here, try to set up the camera so you can see it, you'll see there's a hook up there at the top. So I went and bought a $5 hook. You can get it at Dollar General or wherever. So that way that string is for your pendulum is out far enough from the wall so that your bob at the bottom. I'll show you the bob at the bottom. There's a string that goes down to the bob that you have to measure out. It has to be 25 grams or near 25 grams. It is approximately 25 grams. And I took a picture of that so I could send it in for the lab. You can also see at the bottom here. Let me move the camera now. You can also see at the bottom here that I took my ruler that comes with the lab kit, and I put the bob right at 50 centimeters down here. Okay. The string is exactly from the point where it connects with the bob all the way up to the bottom of the hanger up at the top. That's 100 centimeters. So it's important that you take your time and set this up on a wall. I would recommend being careful what kind of tape you use, because and depending on what kind of paint you have on your walls or whatever your walls are made of, the tape can definitely tear it off if you're not careful. You'll also see at the top there I have a protractor. The protractor is up there so that the string is in line, or it's parallel with the 90-degree mark, so it's 90 degrees going straight down. And that's pretty much it for the lab setup. I also did some practice runs and stuff before I started this video, just so I had an idea what I was actually going through. And doing walkthroughs through your lab, going through it a couple times, doing a couple practice runs can help you get better, precise and accurate information or data. So with this lab, I'll kind of go through steps 1 through 10. Steps 1 through 10 of lab 4, and this is for Thomas Edison State College or State University. Their lab 4, the pendulum and calculation of gravity. All right, so if you look, step 1 says attach a small plastic bag to the spring scale. Add washers to the plastic bag until the scale measures about 25 grams total. The filled bag will hereafter be referred to as the bob. So I already have that set up. I recorded this value as mass of the bob, and the mass of the bob is 25 grams. Now I'll have to convert that to kilograms later, which isn't too bad. Measure a piece of string that is approximately 120 centimeters in length. So I did that first when I cut my string. So you definitely want to give yourself a little extra string, because when you tie it, one of the things you have to do with the bob to get the 100 centimeters, I laid out the hanger with the bob attached to the string, and I used my ruler first before I taped it up on the wall to measure it, to get it, to tie it up so it was actually 100 centimeters long before I hung it up on the wall. That was the easiest way to do that. If you try to hang it up on the wall first, you could do it that way, but it was much easier to do it on the ground so I can get it exactly at 100 centimeters. All right, step number 3. We already did that. Okay. Step 4, use a tape to affix the protractor behind where the string is attached to support, so you can measure the pendulum's amplitude in degrees. The center hole in the protractor should be located directly behind the pivot point. All right, so that's the closest I got it to the pivot point there. And the center, the string should hang down straight so that the string lines up with the 90-degree mark on the protractor. See the figure below as an example. So on here it shows you a figure. I don't know if you can see that in the lab. You should have that, and you'll be able to line up your pivot point so it's at the 90-degree mark. Step 5, stretch the measuring tape horizontally and use the tape to affix it to the wall or door so that the 50 centimeter mark is directly behind the bob at rest, which it is. All right, then the next page, or the page before that, kind of gives you another setup to show you the points. Talks about the bob's trajectory, angle, string or rod, and the pivot point and the amplitude. And the amplitude is just the distance between the 2 points of which my pendulum will swing, or my bob will swing, based on where I started from. And I'll tell you, one of the hard parts is you don't want to push it, so you have to learn how to use your hands or your fingers to kind of hold it in place and then just let it go. Start your stopwatch at that moment to get accurate measurements. Step 6. So I'm going to show you how to do it from the 5-degree mark, and then you can do the rest after that. And kind of show you how to do standard deviation, calculating the average and everything, so you have an idea how to kind of go through this. All right, so hopefully get the camera set up. I'm going to kind of push this back, and hopefully you could see, all right, that part. So the first mark we're going to go to is the 5-degree mark and hold it there. Then observe the bob's location during the first cycle as it swings relative to the tape measure and record the distance in centimeters as amplitude. So I already did a run on this a couple times, and what you're going to see, which will be hard to see on the camera because it's so far away, is that it's going to go from approximately 4, so it's centered at 5, 0. It's going to swing from 4 centimeters to about 5, 6 centimeters. So if you do the math, that's 6 plus 6 more. It's about a 12 centimeter amplitude. So from back to forth, or going back and forth. So the hard part is you want to center yourself, your body, looking at straight on the string, so you know you're going to 5-degree mark. And when you look at the protractor, the 5-degree mark is going to be between the 90 and the 100. When you look at it, it's going to be right in the middle there. So I hold it at the 5-degree mark, and I'm looking at it, judge it just right, line it up, and then this is going to be the fun part, just letting it go, not actually pushing it. And you want to do a couple runs. So there we go. We're going back and forth 5 degrees, and I'm looking down at my tape, and I'm looking at it's about 4 is the farthest point that way, and then it reaches 5 6, farthest point to the right. And you do this a couple times until you get pretty much good at it, and then you'll get better readings. And it is important that when you do let it go, you want to let it go so that the pendulum or the bob is going to go in a straight line from right to left when it's relative to the wall. So it's not bouncing off the wall. It's not going in a weird motion. You just want it to go right to left, nice and straight. So we'll bring it back here again. We'll do this again, 5 degrees, let it go. And then I'm going to observe down at the bottom on my tape measure. And again, I'm getting about 4 to 5, 6. Okay. So that's step 6. All right, step 7. Now this one's a little trickier. Again, you want to set yourself up so that you can see. You want to get an accurate 5 degrees so you can get it lined up right. And then start your stopwatch. So I hold my stopwatch. I'm right-handed, so I hold my stopwatch in my right hand. It's a little easier for me. And then I'm going to time 5 cycles, so a complete cycle. So this would be, you watch the bob at the bottom. 1 cycle would be, that's 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles. That's a cycle. So now I'm going to line it up at 5 degrees, and I'm just going to let it go. And right when I let it go, I'm going to start my timer, and I'm going to time how long it takes to do 5 cycles. Here we go. And start. There's 1 cycle, 2 cycles, 3 cycles, 4 cycles, 5 cycles. All right, so that's about 9.66. And what you'll find, it takes roughly about anywhere from 9.66. I got my first run when I did this to put it in my data. I got 9.91, 10.01, 9.85. So anywhere between 9.5, 10, or maybe even 10.0 something or whatever, you're going to be pretty close. And the stopwatch I'm using is doing, it's not you're looking at 9 seconds, and it's doing all the way up to the hundredths of a second as well. So the stopwatch comes with the lab kit. All right, so you do that 3 times. You're gonna do the 5-cycle experiment. You're gonna do that 3 times. And you're gonna write down values. And if you look at my chart here, let me do my math real quick. So that's gonna be 12. Okay, so if you look at the chart that they give you with the lab, you're gonna put your horizontal amplitude or displacement here. Then trial 1, 2, and 3. Those are your 3 measurements of the 5 cycles. And then you're going to take the average. And the average is just adding all 3 of the, trial 1, 2, and 3 divided by 3. I came out with 9.95 on my first run. And then you can take that information from your trials and you enter it in your calculator, your graphing calculator, get the standard deviation. So that's where you get to like steps 8 and 9. So step 8 says repeat the experiments for trials 2 and 3. Again, I would just do the timing thing again. And then step 9, calculate the average and standard deviation for the period it takes the bob to complete 5 cycles. Pretty easy. Average, again, for my numbers, I came out with 9.91, 10.01, and 9.85. When I add all those together, divided by 3, I come out with 9.95. All right, and then it says do the standard deviation. So here's how you do standard deviation. It's actually pretty easy. You can go online, YouTube it. There's all kinds of videos out there that show you. Our professor had a video link at the very beginning of the course to show us how to do standard deviation on a graphing calculator, but I'm going to kind of step through. Hopefully you could see as I push on the button. So you turn your calculator on, hit stat, and you're going to see a screen where it shows you to go to edit. You want to hit enter. After you hit stat, that'll take you to the edit screen. And if you notice on here, I already had mine set up for standard deviation. All I do is enter in the number for each entry, and there's 3 total. So one of the things you'll find is if you accidentally, so I'll show you, if I accidentally put 4 things in there, or let's see, something like that. See how I got 4 lines? If you do that, no big deal. You just press the up button all the way to the top. Oops, I went too far. There it is. Okay. See how the L1 is now highlighted in black? And then you just hit clear and then hit enter. And you'll notice it resets everything. And that's important to pay attention to, because sometimes you can have, if you leave one of those blank or you put the wrong numbers in or you have too many, your standard deviation is going to come out wrong. So I'll go through my standard deviation for my first run. So 9.91, and then I hit enter. So as you can see, that's my first line there. And then I go 10.01 for trial 2, enter. And then 9.85, enter. And that's what it should look like when you enter it into this type of graphing calculator. And notice the bottom one still has the dashed lines and it's in black. Okay, so now after I do that, then all you got to do is hit stat again. So after I hit stat again, this should pop up on your screen. And then you press the right over button to get over to calc. And then the first one, it says 1 variable stats, or 1 tac var space stats. Hit enter. This will pop up on your screen, and then you're going to hit enter again. And now you'll see it comes up with your standard deviation. Now the standard deviation is the number we're going to use is the one with the capital S and the lowercase x, if you can see it on the screen. So the number you're looking at, the one I'm looking at, or I'm going to use is 0.08082 and so on. All right, and that's my standard deviation for that run, that trial. So I'll put that in the column that says standard deviation 5 cycles. And it's also important to know that you got it right, your standard deviation. If you look at the bottom here, you're going to see a 3. All right, n equals 3. That's what you should see, is n equals 3. If you see any other, you did 3 measurements in that trial. If you see 4 or 5, that means you entered it incorrectly when you were doing the edit phase. All right. It also tells you, so that's step 9. Step 10, it says to divide the average value found by 5. So my average value was 9.95. You divide that by 5, you come out with 1.99. So that's an idea on how to do this. Again, everybody's going to have a little bit different measurements and accuracy and stuff. It depends on how well you use your stopwatch and how well you let go of the bob, but it takes practice, so you definitely want to walk through it a couple times before you start recording data to get the hang of it. And that's it for lab 4. There's obviously you'll do 10 degrees, 15 degrees, 20 degrees, 25 degrees, 30, and you'll record all that data and put it all together. And then you go through and answer all the questions. I hope this video helped you out, and I'm Craig Double. Have a great afternoon, and we'll see you again.